If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
So, okay, now we are getting into the second portion, that is Dockers, where I'll explain you what is a Docker, what is an image, how to build an image, everything. After certain explanation, I will just walk you through, how to build a Docker container, what is it exactly, and I will also show you at the end of the demo, one installation that we already have. How does it look like in a data intelligence installation? So what are all the pods that are available? How, something like that, I'll just show it to you, so that in case tomorrow if you have to see, this will be a good knowledge session for you, right? What is a Docker? So Docker was essentially a need to come out of a problem that I'm going to tell you now. Okay, now I will give you a scenario. Imagine yourself as a developer. Okay, you're developing some application, so probably you're creating a website using HTML applications, PHP, or whatever it is, whatever the programming languages. The first thing that you do is write some code and test that code, right? So the kind of environment that you would be putting this code is something that we will have a look into it now, right? So we have okay, so we have a developer here, and then we have this box, and then we will see what it is, right? So as a developer, what is the first thing that you do, right? So you are creating an application. Now, what is the environment? The first thing that I would need is operating system, correct? I need an operating system. Now, on top of operating system, what is it that I need? I need a programming language or a development language software like HTML or Visual Studio Code or PHP or whatever it is, right? So to develop my application. Now, apart from this, we would also have to take into consideration the third-party libraries that we would be including in our code. Let's say, for example, if you have a PHP system or probably connect to a database, right? Like SQL Server or MySQL, correct? So this is an application layer, and this is going to be the DB layer, right? So this has to talk. So for that, we would need some binaries which allow the application layer to talk to the database layer. Now we need to, I'll just put in the libraries here. Okay. So these are all the three important items as a developer that I would require. Now, what is a common issue that we face, right? Now the development has, now assume that you have completed the development. Now the next step is testing. Correct? So the next in the process is testing. Now, testing, what you will do in the normal traditional way, what we will do, yes, the developer is complete, now you can go ahead and test. So the developer will also try to mimic the same environment. He will also have the same OS, he will also have the same programming language environment, and he will also having the same kind of libraries, right? But guys, you would have been hearing this multiple times, n number of times, being a developer. Boss, this is working in my system. This is definitely. How many of you have experienced this? I mean, people who actually came from QA background or development background, right? In the traditional waterfall model, if you are following that, how many of you has actually experienced that? It is working in my system. It is definitely not working in my system. So in order to eliminate all these systems, right? That's why we have the Docker containers. So how Docker containers will eliminate this particular challenge that it is working in my system, it is not working in my system. How can it provide a seamless way or provide a seamless environment for both the developers and the testers to test the same application in the same kind of environment, so that they don't have fault. Even the testers had developed, the tester was also using the same OS, same probably environment like what the developers were using, but there could be minor changes, like some libraries would have been missing, some libraries developer would have added which he would have forgotten to include and or inform tester, something, right? So now, what is the solution? Okay, before Docker containers, what is the solution that people would immediately think about? Correct? So you might think about a virtual machine. Correct? So we have a virtual machine. You might immediately think this is the solution. Why don't we create a virtual machine?
So essentially, when we talk of Docker, so Docker is, it solves a problem. And the problem that it solves is it enables environment to be ported from one place to another place, right? So it is nothing but, your OS gets packaged, your entire OS, your softwares, your solutions which you have, they get packaged into one container, right? And then this container can move around. You can, deploy it on any, classic server. Doesn't matter which one, right? So this is again based on the concepts of virtualization, but essentially the point is that the container is immutable and it cannot change, and hence even if you change the environments, everything comes with that, right? And having said this, sorry, yeah, and having said this, how it translates to data intelligence. So there are a couple of things. So first thing which we have already seen, and that is the way our DI modules are built, right? Each one of them has their own image, and that is how it gets pulled from SAP's repository. So repository is nothing but where you store all your images, right? It's similar to a GitHub repository which handles code, right? So there is also a similar concept in the era of containers, that there are container registries. In Azure, we have Azure Container Registry. Amazon also provides the same. So it's basically this things are same, but providers are different, right? So even in the installation process, what happens as a first step is, once you give your credentials for your own repository and credentials of your SAP, that is the S user, what happens is these images are pulled from SAP's repository to your own repository, wherever it may be, right? Hence, the software is packaged into one container and it is downloaded into your own repository from then on, where the installation begins automatically, right? So we in the installation, right? So only in that part, the installer will take care of which module has to come first and which has to come second. But otherwise, in the area of modeling, we have to handle it by hand. We have to create all these environments by hand. So when I say an environment, right, when I say an OS, when I talk about virtualization, so I essentially mean a bunch of things. So the first and foremost thing would be the OS.
In case, so what is the other option that people would think, okay, why don't we in this cloud world, right? Why don't I spin up a virtual machine, I develop an application and give the same virtual machine access to, the tester, right? So that is also a very pretty viable option. I do not say, that is not a wrong option. So now what is the problem that this again creates, right? So what is, say for example, what is the size of the VM that a developer is going to give it to the tester, right? Say for example, if this is going to be a 32 GB RAM VM, now it should have some persistence. Say for example, this is have 100 GB HDD. Now I'm going to give the same VM to the tester. Yes, no problem. The tester can test, he can validate it. But do you think it is possible for each and every developer to have their own VMs? Right, so developer 1 might have used this VM, developer 2 might use another VM, developer 3 might use another VM. Do you think is that possible? No, absolutely that is not possible. If they have to test all the features of all the developers, then as a tester, okay, assume that I am a tester, I'll be end up having 100 VMs, more than 100 VMs. Okay, for each feature or for each application, I don't know which VM I have to test for whom. So this will create a lot of chaos, right? Now you got a clear understanding, right? Why we should not use VMs. This will definitely create a lot of problems. One from infra perspective, that is one from licensing point of view. That is, say for example, if this is going to cost you like $0.05 per hour, then imagine if you have 10 developers, 10 virtual machines, it will easily cost you $0.5 per hour. And then imagine how much it is going to cost you for a month, and how many VMs are going to be there, how it is going to be tested by the tester, how they are going to maintain it. So all these overhead facilities are, these are all some of the problems that when we use a VM. Okay, so this is also not a possible option now. So who is coming to the rescue now? So we have the containers to the rescue, right? So we have the containers to the rescue. Now, what exactly a container means? The proper definition of a container is a container is an entity which can contain all the software dependencies and be ported to another computer, like a plug and play device. It is like a packaged solution which can be ported to any other device. It's like your USB drive. You just plug it to any device, it will work, right? So even it doesn't know who is a tester, it doesn't know who is a developer. You just plug and play, it will work. In a similar fashion, as an analogy, you can consider as USB, right? So you can bundle all the software dependencies and then give it as a container to the tester so that they will be able to test it in the same environment like how the developer has tested. Not even a single binary will be missed out. So this will eliminate the problem of it is working in my environment, it is not working in your environment, because here ultimately the tester would end up using the same environment what the developer is using. Okay, say for example, I have the developer here, and I have the OS libraries, and I have the software, right? So what I will do is I'll create a wrapper, right? I'll create a wrapper around this. Container is like a wrapper, okay? So I will just, tell the tester or people whomsoever is testing. So this wrapper, which will basically contain all the required files for running the application successfully. So these wrappers will be delivered to the testers. Okay, so testers will then test in the wrapper. So this wrapper will consist of all the OS libraries and the software used by the developer. So the testers don't need to worry about the underneath platform, what has to be configured, what has to be used, what binaries has to be used, what software I have to install. No, those things are already eliminated. Everything here will be shared to the tester and it will be done. So, and one more advantage is tester, assume that this is a QA environment. We have OS, library, and software, right? So this is a wrapper. So after tester testing this wrapper, this container, if tester says that everything is looking good, the same image. Okay, I think I have to charge my pen. Sorry guys, sorry about that. But what the tester, what he will do is the same wrapper he can also deploy it in the production. Right, he can also deploy it in the production. So it doesn't also, you also don't need to worry about whether it is a development environment, whether it is a production environment, whether it is a QA environment. No, I wrap it, I give it to you, you test it in whichever environment you want. If you are happy, deploy the same container in the production environment also, right? So this is the main funda. Now I will, in the demo, probably I'll take some more time to explain, few of the stuffs, right? So in the demo, what we will do is I will show you how to create a container from scratch. What do I mean by logging into the container, seeing what services that we can start, everything I will show you. Okay, you don't have to worry about that. So Docker is a computer for a proper definition, right? If you require, a Docker is a computer program that helps people in creating a wrapper around the files of code, right? So that might include operating system files, libraries that we have already mentioned. So this is what it is. Now, unlike VMs where we told, right? So if you have a 32 GB RAM and 100 GB of space, so what is the, people will ask us, okay, container also, if you're wrapping your OS, if you're wrapping your libraries, if you're wrapping your software, everything you're wrapping, so containers also will be huge in size. Is it right? Can anyone tell me? See, what I told is developer will wrap the entire environment, correct? OS, if he's using Ubuntu, Fedora, whatever it is, or Windows, whatever it is, and library, software, I'm wrapping the entire thing, right? Correct, guys? I'm wrapping the entire thing and then I'm giving it to the tester. Now, when I wrap the entire thing along with the OS also, obviously Windows OS is of 7 GB or 8 GB or 10 GB in size, right? How can I give it to the tester? How will I transfer the files? How can I do it? Can anyone tell me why? Will it be possible? Please open up your mic, guys. So if I have to wrap up my my OS library software, it will also obviously say, for example, equivalent to 10 GB or 20 GB. I can easily go for a VM itself, right? I am saying it is portable like a USB. How is it portable? When you say something is of 10 GB or 20 GB in size, how is it portable? Can any one of you tell me? When I say OS, It is not the actual OS. It is only the required files that are necessity to run the OS. Let's say, for example, if you have an Ubuntu image, so Ubuntu operating system itself will be around 2 GB or 2.5 gigs. But when I create an Ubuntu container, you will see the file size as 85 MB, only 85 MB, if I'm not wrong, right? As of today, I think it was around 85 MB. So you can see already the difference. Ubuntu OS is 2 GB and this container is just 85 MB. How does it work is, for spinning up the container, it requires a minimum files, that minimum files will be there. Okay. What about the other files which are required by my application, which are provided by my operating system? Who will provide it? Right? How will this container know which kernel I have to use, or what is the process that I have to use? Okay, you have the minimum files to spin up an operating system, fine. But my application requires more. My application, if I have to run in this container, it requires more processing. It requires additional stuffs which can be provided only by your original operating system, which is of 2 GB or 2.5 GB. So how does this work? How does this funda work? Right. So for that, I will have to explain you a concept. Okay, so now this is one architecture which I would like to explain you how it works, right? So we take laptop as an example. Okay, our laptop, whatever we are using our laptop as an example. So laptop is the hardware, right? Everyone accepts. So my laptop is a hardware and an operating system is installed on my laptop. So we are done. The hardware is the laptop and operating system, I have a Windows or I have a Linux. So for easier understanding purpose, we have a Linux as an operating system. Now on top of it, I have the container engine installed. Okay, in my operating system, in my laptop, I will install container engine. So guys, when everyone talks about Docker containers, they think it is a technology. Okay, so one way they are right, one way they are wrong. Containerization is a technology, that is right, but Docker is a company name. Docker is a company name and Docker containers belong to Docker company. Okay, so you have also other competitors like Mios, if I'm not wrong. That is also one of the company which provides you containerized technology. So containers is a technology and Docker is a company which are using this. Okay, so I installed Docker. Okay, I installed my Docker, which is the container engine. I install it on my operating system. Now I will spin up a container here using my container engine. I will spin up an Ubuntu container. Okay, now we have the hardware set, we have the operating system set, we have the container engine set. Now what we would do is we would install containers. We will be running containers. Say for example, if my application that requires Ubuntu, I would deploy a Ubuntu container. If my application requires a Fedora OS, then I would deploy a Fedora OS container. Guys, you are already able to see the advantage here, right? On top of operating system, I can have multiple containers with multiple operating systems. One container for Ubuntu, one container for Fedora OS, and one container for any other flavor of operating system. But the base operating system is what I'm using. My hardware is my Lenovo laptop. My operating system is my base operating system is my Ubuntu, and I already have spinned up an Ubuntu container. I have already spinned up my Fedora container and one more other container, right? So I have 3 containers running. So to answer I have already answered the question how it is low in size, because it only has the required files to spin up the container for that particular OS. Now, so a container does not have a kernel. Okay, so this is one of the main understanding. So if you are creating an application which is using some of the operating system processes, how the container will able to cater to it if it is very small in size. A container does not have a kernel, so it shares, right? It shares the kernel with the operating system. Let me check whether my pen is working or not. So it shares, okay? So it shares with the operating system. It shares the kernel. Whenever it is required, it talks to the underlying operating system and then it gets the required processes and it serves your application. Now you got the point, right? How actually the container is working. So why it is low in size, and in case if it requires any other processes, where it has to reach to, it will reach to the underlying base operating system. It shares the processes with the base operating system and then provides it with your provides it to your application. Got it? Any questions?
So the only thing is just that like when you shares that it's that the kernel process is the one that really like reach out to the underlying operating system, and then it talks to that, right? Like it pulls the required you know the components or like additional things that what we needed to run the applications on the wherever you deploy that image, right?
Yes, you're absolutely right, Murli. You're absolutely right. So whenever it is required, it talks to the operating system and gets the thing. It shares. That is why it is very low in size. And whenever your application has a dependency on certain operating system processes also, you don't have to worry at all. So same laptop, I can have three different applications. I'm saying three different applications. Say, for example, I have my e-commerce application running on Ubuntu. Yes, one container, I will deploy it. It will run properly. I have a booking, ticket booking application running on Windows. Yes, I can spin up a Windows container. I can do it. I have another application running on Fedora OS. Yes, I can do it. One single laptop can cater to all these three applications running on different OS. Right. So I don't have a clue about how Windows Docker works because I really haven't worked with the Windows Dockers, but I have good experience with Linux Dockers. Right. So here, assume that my core operating system is Linux. Now, what will happen is, say my core operating system is Ubuntu. So here we have a Ubuntu container, Fedora OS container, and probably some other container, right? So since the underlying operating system is a Linux kernel only, these three containers, they don't worry about anything, right? So I'm not sure how it is the case with Windows Docker because I have not really worked with the Windows Dockers. So probably they might, adopt the same mechanism. Probably I can get that information. I'll get it to you.
Yeah.
Right.
Okay.
Okay. So this is what I wanted to explain you. And now you are able to understand, right, how different it is from a virtual machine. So virtual machine, you will have one more additional layer here, hypervisor layer. And then from there, you will spin up the virtual machine. You will have guest OS. And then on top of it, you have other applications. Correct? So this is the difference between a virtual machine and a container.
Yeah, we can see your put screen, Venkat. But before we go there, just one point from my side. I'm sure all of you would have heard the name hypervisor, right? You have heard now something called containerization, and then there is something called virtual machines. So Venkat has already clarified, the differences between a virtual machine and a container. But how does hypervisor relate or differ with containers? I will tell you, because I'm sure we would have encountered the Hyper-V. Hyper-V is the name of the hypervisor for Windows. So how that works is, so hypervisors are essentially, we have two types. One are bare metal ones which run directly on hardware, but the number two one, which all of us would have encountered one way or the other, is the hypervisor which works on top of the operating system, right? So this is the most important part, that hypervisor work on the OS, Docker works on the kernel, right? But hypervisor, as in your own laptop, for the more people inclined toward Linux, you might have had two OSs on the same machine, right? One might have been Ubuntu, one might have been Windows, right? Or for those having Apple, they might have also have Windows, right? So this is only possible because you have an hypervisor. Hypervisor can support more than two operating systems, more than one essentially, right? But the Docker, it only sits on the top of the kernel, which is why it can do so many things, and which is why it, all this was born out of a need in the industry. It is not like somebody, essentially invented it. It's essentially a need which was born out of the want of having immutable environments across systems, across servers, irrespective of hardware. So that was a need, and which is why we use Docker as the preferred deployment option rather than a hypervisor or a VM or others, right? So this is the classification where Docker differs and how we use it also.
So even with hypervisors, so again, it can be more than one operating system, right? Not just, obviously it's going to be stick with the very, one or two or something, right? You give an example of Apple with Windows,
Yes.
right? If you want to go with anything else, another operating system, we could extend that, right?
Exactly. Yeah. But the
But
Docker, it is built on one image. It can be only one image. It can be Ubuntu one. It can be,
Right. So
SUSE.
whatever image that brings in, and it goes only stick with that. So that image,
Yes,
and you
yes,
can just more of like your scale in, scale out kind of thing, right? So
exactly. You can make 100 copies. You can make 500 copies. So it supports only one OS, and after that you can install whatever you want to install, any EXEs, any packages, any softwares, any SDKs, right? So all
yeah.
those you do after you specify the base image.
Correct.
Yeah.
okay,
So, one question.
yeah.
You said that hypervisor operates on multiple OS, but Docker operates only one kernel or built in on only one image, right?
Yeah.
So, whenever required, hypervisor gives the virtualization of the guest guest servers, I can say, right? Means as and when required, it can scale out more guest servers, and when it is not required, it releases those guest virtual machine. Now, how the Docker works then? Is this replicate the image on those guest virtual machines?
No, so yeah, Sutapa. So there are a couple of things here. There is one thing that is about Dockers, right? The second thing that you're referring to is the management of containers, right? So these are two
Mm-hmm.
completely separate things. So right now we were just talking about the capabilities of Docker, capabilities of hypervisor, and capabilities of the VMs, right? And we came to a conclusion,
Mm-hmm.
with examples and understanding that in a immutable environment, for an immutable environment of applications of supporting libraries, the preferred way is Docker, right? But then naturally the problem comes, if you have one Docker, yeah, fine, that's okay. But what if you have more number of Dockers? What if you want to distribute jobs, or if you want to distribute it processing, if you want to get the results back from them, right? So when this part comes, right, when you are talking about a group of Dockers, that is when the management of containers comes. I would like to say it as a container, not a Docker, right? So once you have single container, that's fine. But when your number of containers increase, we need to have management, right? And that is what we call as container management, right? And this is
Yeah.
also a term which we all know, that Kubernetes is one of the leading container management technologies out there. It was created by Google, right? Again, it was a need.
Yeah.
You can do something good, but unless you can, do it something else at scale, it's a failure. So that is where Kubernetes comes in. Kubernetes nothing but container management. If you want to organize, add, replace, deploy, manage, scale, networking. So Canico is the networking, part which we use within Kubernetes. So how do you network between 5 machines, between 500 machines, right? So that is where Kubernetes comes in to manage the containers. So there are many things, which Kubernetes does. For example, like health, managing the health of pods, of machines, replicating, balancing the load, allocating hardware resources, right? So, I mean, so yeah, so based upon the capabilities of Docker is where Kubernetes comes in and says, one Docker, it's fine. If you have thousands of Dockers or, tens, 50s of Dockers, I can help you manage them at scale, which is where container management and Kubernetes comes in. And as you know, we have been talking about scalability. This is how it has evolved, and this is why when we say DI is scalable, these are the concepts behind it. First concept is the container, which we will cover Docker in detail. Second step would be managing multiple containers, that is Kubernetes, over which DI is based. So Kubernetes is a container management platform, DI is a software, right? And that's how it's being managed. So this is the entire history behind the same. So now what Venkat will be demoing is the is how do we create a container, how do we deploy it, how do we do all the basics of it, starting from the intro. I think intro is done. We will be jumping into the
Okay,
So
practicals of it.
thanks.
don't worry, Sutapa. So after this Docker, we are going to cover Kubernetes in depth. Okay, so that you will understand how it is also there. You can connect the dots, and then you will have a clear end-to-end picture, right? So now, probably even after this intro, some people might be wondering, still they will not be very clear about what is this, what is the container. So for those people, probably this hands-on will be a solution for you. I know a few people will be able to get it, but few people, even considering myself, only when I see it in action, I'll be able to understand, rather than the explanation that we provide. Okay, so now I am inside a Ubuntu machine. Now consider this is your laptop and this is your Ubuntu machine that you had already installed. So what is the first thing that we do is probably I do a repository update, right? Sorry, I do a repository update. So apt get update is the Ubuntu command to update the repository that is available within the Ubuntu. So I'm using the sudo because I don't have the root username and password. So I'm just using the sudo. Now my repository has been updated. So what is the next thing that I have to give? I have to install the Docker, right? Now I have to install the Docker. So where will I install the Docker from? So I will install the Docker using the command sudo apt-get install docker.io, right? So as soon as I give sudo apt-get install docker.io, it is hitting my repository. Yes, Docker is there. So now shall I go ahead and download this? Done. My Docker will be installed. As easy as it is. You see how much time it took me for me to install Docker, right? Just one command, my Docker is installed. Okay. Now, what is the next step that we have to do? Let this Docker get installed. Now this will install all the packages required for the Docker software. Now once this is all set up, we can check whether the Docker is working by typing a command. Probably we can just check the version of what Docker has been installed on our machine. So in the interest of time, right? So I will also cover one more quick concept, Docker Hub, right? So you people have experience working with GitHub, right? So very similar to GitHub, we have a Docker Hub where you can, it's a central repository. You can push the images and also you can pull the images, right?
It's similar to GitHub, right?
Exactly, similar to GitHub. So you have a Docker Hub where I have created an account. I will show you. In this demo, I will show you how to push the images to the Docker Hub so that even other colleagues can pull the images from the Docker Hub from the repository that you have, put in.
So this you are installing in your machine right now, Angat, or where are you
Yes.
installing?
Yes, this is, see, for you, I mean, if I have to say, I have spinned up a virtual machine and on top of virtual machine, I'm installing a Docker, right? So for people to make it easier to understand, just consider this as your laptop and you have an Ubuntu machine installed and you have the access to the CLI, right? So you have the command line access to your Ubuntu, and from the command line, what is it that you will be doing?
Okay.
Okay, so this is the Docker image and Docker is installed. So sudo docker version, let me check. Oh, sorry, sudo docker version. Okay, so we have the Docker version 1903 something. So just to check whether the Docker has been installed properly or not, right? So now what we do is we will just perform few Docker operations. Now what I will do is I will pull a Ubuntu image from the Docker central repository. So sudo docker pull Ubuntu. So guys, what is it I'm doing? So I have downloaded an Ubuntu image from the Docker central repository, right? As soon as you install Docker, so Docker will have some public repositories which will be available for you to use, like Ubuntu image, Fedora OS image. A lot of images will be available. So by this command sudo docker pull Ubuntu, I have already pulled in the Ubuntu image. Okay. Now, how to see the images that I have pulled? Docker images. Sorry, sudo docker images. Right? Let me clear the screen here. Okay, so we have the image, right? You are able to see the Ubuntu image, and we have some image ID and the size. Guys, can you look at the size? 72.9 MB, right? Like I told you, this is a proper Ubuntu image, so which is running on Ubuntu, which is nothing but your Ubuntu OS, but it is size only 72.9 MB. So this image will have only the required files that is necessary to run a basic. You can consider this as a mini OS. Your mini OS running inside your major OS, right? So which is only 72.9 MB. So, and now what we will do is we will run this image. Okay, when I run this image, it is nothing but I will automatically spin up the container. When you run the image, the container will spin up, right? So I will just say sudo docker run -it for interactive mode, and then the image name -d, and then the image name. Done. So something has come, my Docker image has run, and it is giving me some kind of ID. Now, what is this ID? So, and the parameter -d, it means that it will run as a background job until I explicitly stop it, and ID is interactive. So now, when you run the image, it will be a container. Okay, the image will be running inside a container. Now, how do you see the containers which are running? Sudo docker ps. Okay, so if you see, this is the container ID, so which is automatically populated, and I think this is trimmed. So this is the longer version of this thing, and this is the trimmed one. And we have the image name, and we have the container running. Okay, so now what is the next step that we have to do after running the container? Now, how do you stop a container? Very easy. You just have to do a sudo docker stop and then the container ID. So I'm not going to stop the image now. I'm not going to stop the container now, but in case if you have to stop the container, you just have to give this command sudo docker stop and the container ID. It will stop the container. Okay, now there is also one more command, sudo docker ps-a. Now what is the difference between ps-a? So what is the difference between sudo docker ps and then docker ps-a? So -a will give you all the containers which have been running or which have been stopped also, but docker ps will only give you the containers which are running at that moment. Okay, that is the only difference. Now, we had been talking a lot about this image, and we had been talking a lot about this container. Can I log into the container now? I am an application developer, right? Consider this scenario. I'm an application developer. I have to develop an application on Ubuntu, and I have to wrap it, and then I have to give it to the tester. Now I have downloaded this Ubuntu image. I have to spin up the container. So what should I do from here onwards? How shall I develop my application on this environment? Or how shall I do some changes in this environment? And then I wrap it, and then I give it to the people. So we have to log in to the container. Okay, we have to log into the container. So what is the container? What is the command to log into the container? So sudo docker, it is exec execute, and then interactive mode, and then I just have to give the container ID here. So I just copy, copy, and then I paste it, and then okay, so this is the command. It is not complete yet. So sudo docker execute interactive mode container ID, and then I have to give the bash, because bash shell for Ubuntu, it is the bash, and it will take me directly to the container. I am inside the container now, guys. You're able to see the difference. Root at my container ID, here it is admin123 at docker VM host. You're able to see the difference. I'm inside the container. I'm inside the Ubuntu. Now, if I do a ls-l, I'll be able to list the files that have come along with this Ubuntu image, right? Say, for example, I do a sudo command not found. Can anyone tell me why this is coming here? Till now, we are using sudo, but now sudo is not working. Why? Can anyone tell me, please?
I think like we come from the admin to inside a container specific.
Yes, you're absolutely right. So we have come from our machine, and then we are logging into the Ubuntu container. We are inside that Ubuntu. Now this Ubuntu does not have the required library, or this image does not have the required library to execute the sudo command. So this one is missing, right? So I told you, right, it only has the bare minimum libraries to spin up this entire container. So this is not available. Okay, now we have logged into the container, and then we will just do container repository update, apt get update. Sorry. So I'm just updating. I'm just updating the repository that is inside my container. Okay. So now the repository has been obtained, and probably so we have a few commands to remove the images also. And let me say, I'll just give you also one example, mkdir, and then I'll just put it as TCS and ZaranTech, right? So I'm just creating this particular directory. If I do a ls-l, so I'm able to see the directory, whatever I had created here, correct? Now I am doing an exit command. I have come out of the container. I am doing a ls-l. See, nothing is there, right? So I don't have anything because I have created that directory inside that container. So it will be available only within that container. So in order to remove a container, what is the command that you have to use is sudo docker rm, and then your I have to get my container ID, right? So what is the process to get the container ID? Sudo docker ps, and this is my container ID. Yes, so sudo docker, and then rm is remove, and then I have to give the container ID 7742 or whatever it is. So I'm not going to remove the container now. I'll just keep it as this, right? So now I do a ls-l. I'm not able to view the directory, but if I log on to the container, I would still be able to see the directory that I had created. So what is the command for us to log on to the directory? So we have sudo exec -it, and then container name and bash. But I'm just reusing the history that Ubuntu shell maintains, and then I'm using this. So I'm again logging in ls-l. I'm able to see the directory because this is totally independent of whatever you had created outside or inside your machine. Okay, so this is totally, whatever you do here, it will stay within the container, and it will be totally independent of the outside host or the machine that you are already in. So now I will just show you how to create a Docker Hub account. Probably, I'll just take some. Just let me know once you're able to see my screen. I will just open the Docker Hub account here. I have not yet shared. Just give me a second. Let me know once you're able to see the Docker Hub screen. You're able to see it?
Yeah.
Okay, so this is the Docker Hub account where it acts as a central repository, and you can push or pull images from here. I have already created my account. So Venkat9890 is my account, and see, you have already world's largest library of container images. These are all predefined images which you can directly use, like how I did, right? Docker pull Ubuntu. Same fashion, you can also pull any of these images which are already available, and then you can use it in your repository, or you can create a container out of these images. Okay, so let me just switch back to the terminal, and then we will see what has to be done. So now just an example, right? So we will just try to install an Apache server there, and then we will see whether it is working. We are able to access this Apache server from outside our host, right? So we'll just what we will do is I will just run. The container is already running, so I will just log on to the container. Okay, again I'll just log on to the container. Now what I have to do here is I have to say, this is just an example that how I have to create an Apache server, run the Apache server which is accessible for the container. But it was going to be a development environment. Probably in the Ubuntu space you can have your own development environment and do all those necessary steps and then package it as a container, right? So this is the funda is going to be the same, right? Whatever I do, it's just the fundamentals, but it holds good for anything that you do within this container. Okay, so now I have already updated the repository also. So what I would do is I will just do apt get install Apache 2, right? So it is installing my Apache server. So in the meantime, I will probably ask you guys a question. Okay, now I am installing some this in this container. Now what I do is I come out of this container. Okay, I come out of this container and then just a second. I come out of this container. I delete the container. Okay, I did something. I delete the container, but my image will still be there. If you do sudo docker images, my Ubuntu image will still be there. Now I'm again running the Ubuntu image. So when I run the image, it will again take me back to the container. So can anyone tell me if I do this way, will I be able to see the installed files, whatever I had given here?
Yeah.
I don't think so.
Sorry?
It will
No,
not be there.
I think we can know because the image is still available. That image, again, we can pull it with the image ID or something.
Exactly. So this is the answer that I needed from everyone because I wanted to tell you, but unfortunately that is not the case. But this is the answer that I get from most of the people. Yeah, people get confused with image and people get confused with container, right? See, whatever I'm doing, it is inside a container. Whatever changes I'm doing, it is inside a container, right? Now I am not doing anything to the image which I have already pulled from the Docker repository. The image is lying idle, but I'm creating a container using that image. Whatever changes, it is only with respect to that container. Now, if I delete that container, right? If I delete this container, the container will be deleted, but the image will still be the same. But what is that image? That is nothing but the image that we have pulled from the repository, correct? It will still be idle. You got my point, right? Say it is like, you have all the raw materials ready to prepare the food. Okay, you prepare the food, but your raw materials are there. Say for example, you have 3 to 4 raw materials you're cooking, and then your food is ready. Now whatever you're doing is with respect to the food, not the raw materials, correct? You add something, you do something, it is with respect to the food. Now when you throw the food to the dustbin, what you have to do again you have to take out all the raw materials and prepare the same food, correct? The food will not be there because you've already thrown it to the dustbin. But the raw materials still exist, correct? So that is the same case here. Whatever changes you do, that is with respect to only the container. The image is nothing but you have pulled it from the repository. It will still be in the same base image only. So if you want, you can try this out. Probably you can pull that image, you can create the container, you can go through this video again, you can pull the image, you can do some changes, whatever I'm doing, you can execute the same thing. You can remove the Docker container. I've shown you already the command, right? How to remove the Docker rm and then the container ID. You can remove the container. Now create another container. How do you create another container? You just run that image, right? Sudo docker run -interactive mode and then the image ID. Now another container will be spinned up. Just go inside that container and check whether whatever changes you have done is there or not. Obviously it will not be there, right? So now our Apache is installed. We will just have to check whether Apache 2, sorry, I think it's Apache 2. Let me check. Apache 2 status is not running, so we will just start the service. Server name directly global. So fine, I'll just start it off. starting Apache. Yeah. So now if I do a service Apache 2 status, yes, now it is running. So guys, remember, don't get confused. Okay. So we are doing all these changes inside a container, not on the machine, right? So your laptop is different and the container installed in your laptop is different. Whatever we are doing is on the container. Like already I told you, right? We have created a directory, but we are not able to see it outside the container. When you exit the container, you will not be able to see it.
So then whatever we are doing is it in the container, and then if you want to take it again, like, this something has to be replicated or, kind of installed in other things, then you need to again bundle it and create an image out of it. And then you should be
Yeah.
able to, that
Yes.
image will contain whatever you are done, right? So that's how it would be, right?
Yes, you are absolutely right. Yes.
So when we create that, then at that time, when we are packaging this or bundling it, right? At the time, if we are installing or building additional components or building apps or whatever it is inside the container, that could require maybe additional components from the operating system as well. So it would be able to, like, whenever you package it, automatically it detects it and it picks it up, right? So if anything is required beyond,
Absolutely. So it will automatically package it only when it is required. It will directly see. You will, as an end user, we will not be even knowing this, Murli. At the back end, they will be able to talk to the operating system, and then they will be able to get it.
yeah.
Right. So now we have the Apache server started inside the container. So now what we will do here is probably we will just exit the container. Right. Now, if I do a service Apache 2 status, it should show me the status of the Apache 2, right or wrong? So why it is
out
not
of
showing?
container. You're out of container, right?
Exactly,
Yeah,
you are right.
exactly.
So I am out of container, so that's why it is not showing. And now we don't have any Apache server here. Okay, now for people who are wondering, okay, now if I have to take these changes, like Murali had told me, right? If I have to wrapper it and then I have to give it to other colleague, what is the process? We have to save the changes. We have to commit the changes, right? So for that, what I will do is I will do a sudo docker ps. Okay, now this is our container ID, correct? This is our container ID which is running where we had installed the Apache. Now what I will do here is I will do a sudo docker, I will do a commit, right? And then I will give the container ID here, right? And then I will give an image name, Venkat. Probably I'll just say 9890 / my Apache. I hope this should work. So I will tell you why I'm giving in this fashion, this image name. Let's see. Okay, so what is my repository name? Let me check.
So while you are checking that, we would not be, do you think we would be able to incrementally, like, you have taken an image, right? So image one. Now that image one, you kind of put it in the container, and then, you kind of added more features to that. Now you have an image. So do you think those changes can able to sync to the image one rather than I'm creating another image?
Sorry, Murali, I did not get you. Can you come again, if you don't mind?
Yeah, sure. So the scenario which I talked about, I asked you earlier, right? Like basically, like, we are taking the image and then installing additional features or building some additional applications, and then now I bundled it. I bundled it as another image two.
Correct.
Right?
Correct.
So, obviously I can say that, like, this is the latest image. You don't need to use the old image, start using this new image. That's an
Correct.
option.
Correct.
Or instead of that, can I, like, whatever the changes I have made, can I directly sync to the image itself, like instead of creating another image?
No, you have to commit
Okay.
it
I was
because
thinking.
no, you will not be able to do it to the base image. You have
Yeah.
to put the base image and then you have to create a new image, and then you can remove the older image. If you
Yeah.
don't need it, you can remove the older image, right? So it does not have any impact. See why? Because there is a format for you to push it to the Docker Hub. There is a format. Okay, using that format only, you have to commit it to the new image name, and then you have to push it to the Docker Hub, and then they will be other people will be able to take it.
No,
So,
that totally makes sense, because that gives that, like, the incremental and then version control and all those things goes into that rather than really like overwriting it.
Exactly.
But I just curious that, that's all.
So now Like as you see, right?
Venkat,
Yes.
Venkat, yeah, so this container ID 7742 whatever, you have bundled it some new features and create a new image. So Venkat 9890, is this the image, new image ID, or because I can see it is showing under repository.
Yeah,
So
yeah.
The
I mean,
Venkat 9890.
He's pushing to the Docker hub actually.
yeah. I want to push it to the Docker hub, and this is the image ID.
Yeah, that's what I'm saying. That Venkat 9890 is a new image ID, right?
Yes.
After bundling.
No. This is the
Okay.
image ID. This is the image ID, and probably this is the name where I want to, push the images to. So this is the repository. Either I want to push the images to, or this is the repository where I had pulled the images from. Right. So this is the Ubuntu image that we
Okay,
had
okay.
pulled, and this is from the Ubuntu repository of Docker. Okay. Now
Okay, okay.
I do a I do a sudo docker ps. Okay. Now only one container is running. Can anyone tell me why? Only one container is running.
Yeah, we haven't bring that image down again to install it, right? Like, so that's just there. You build it and then we pushed it to that one to the Docker hub. It's still that has to be, you have to install it back, right? Need to be in order to run it.
Yeah.
You have
So
not executed yet.
okay. So now what we had done is we had created an image out of it. That's it. We just
Yeah.
have to create an image. Now how the Ubuntu image, right? Now when we have to log on to this Ubuntu, what we did, we just have to run this image, correct?
Yep.
Now, when I run this image, then automatically, my container will be created, right? So just let me run this image, and then I will just give my this image.
You have to give the new name, right? Whatever the new image.
Yeah. So this is the image. Okay. So I'm not able to copy. Let me check. Yeah. So now if I do a sudo docker ps, you see I'm able to see two containers, right? If I do a sudo docker execute command on this and then I log on to this container, I'm not going to do it now, but if I log on to that container, I will be able to see my Apache running, because this is the container where, I had, this is the image which I had built saying that my Apache should be running, right? So if I'm able to do it, I'll be able to see the Apache that is installed inside that container. So this is how we package the solutions. Okay. Now, let me try to do this sudo docker. I'll just run it again, right? Probably image ID. So iPhone interactive mode. Yeah, what? Okay, so I have to map in order for me to access this Apache server. Right, I need to map. Now I have given something here 82:80, right? So what is this exactly? Now sometimes even in data intelligence, if you're going to analyze the pods in depth, you're going to see the YAML files and other stuff, which I will explain you in detail after this, right? So what is this? This is like I am mapping my host operating system with the container operating system. You got my point, right? So Apache server will obviously run on the default port as 80. Now where we had installed the Apache server inside the container. So inside the container, which is nothing but it's a mini operating system. So I am mapping the container port to our host port 82 so that it will be accessible to the outside port. Okay, so I will just run this again. I'll just give this, let me check what is it. So probably I will just remove this container and then I will try to recreate it again. Okay, so just a second. There is some issue. I'm not able to remove this container.
It says you don't even have access for both the scenarios.
Yeah, it's saying that I don't have the aux, but it's I don't think it's. Let me check. I did not give sudo. Sorry, sudo docker rm-f, and then I just let's. Yeah, there you go. So sudo docker ps. Yes, only one container is running. So sudo docker images. I will list down all the images, then I will execute this particular command. Okay, it's saying that 82 is denied. Okay, let me just map it with 80 and 80. Full access denied. Okay, somewhere I think the port is blocking since I had spilled up this from Azure, right? So this is blocking some port. So probably I'll just have a look into it and see why it is not there. So in the meantime, let me check. Okay, or is it like I have to give the image ID? Okay, now the image ID has to be there. Just okay, some of this port is blocking me, but this is what the funda is. So once you have mapped this right, then you will be able to log on, from your browser and then give the public IP of this VM and then port 82. It will directly take you to the Apache homepage, right? So it will. So what is happening there is you are able to access the Apache server outside the container. And how you are able to access it, because you have already mapped the port number here with the host operating system, and then you will be able to access it, right? So, but this is the funda. Okay, so now you guys have a clear understanding of what we are doing here. What is container? What is an image? How do we run it? Right? Any doubts here? Any clarifications? Any issues? Any doubts?
So now you have created an image with that Venkat 9890, right? So for example, now we are just moved that to the Docker Docker Hub, and then we are just keeping it. What else?
No. I have not yet moved to the Docker Hub. It is still in my local. It is still in my local machine only. I have not yet moved to the Docker Hub.
So, okay. So once we are okay and everything, we are just moving to the Docker Hub. So that can be the first version of that particular image will be there. So in case if we want to do some kind of some more changes or some more features added to that image in other time, so how will it be again? We will be going to create one more new image with a new name, or is it possible for us to do as a second version of the same existing image with the same name or something? We can able to move to that Docker Hub again.
Yeah, so probably you will be able to update. You can pull the same image, and then so as far as I know, we usually give it in the update mechanism is also there in the Docker Hub repository. Also, update is there. So you pull the image and then you do it, and then probably you have to give a new image name, and then it will be available in the Docker Hub. Because right now, if you don't give that image name, right, if you don't give a new image name, then it will be like overwriting the existing base image. So which you can do, but it is not advisable.
Okay, because normally for the GitHub, what we will do, we will use to create one master branch, and then we will use to create some child branch, and then what we used to do, we can pull that from the master, and then once we have done everything, and then we used to sync from the child to the master branch, and then keeping one master at any time. So that's why I just asked whether the same concept is applicable for the Docker Hub too.
Yeah, I mean, for version management, they would have they would have done like this. But still, you will be able to pull the latest images, whatever is automatically updated to the Docker Hub repository, because you will be the only one. See, after all the development is done, only you will be able to push the image, right? It's not like then and there you'll be pushing it. Say, for example, today you're working something, you push the image, and tomorrow you pull the same image and do something, and then push it to the by giving a new image name, you can push it to the Docker Hub repository.
Okay.
Right, and another thing which is recommended for production environments, enterprise environments, is, usually when we have such Docker files, right, these are also locally also, they are stored in GitHub, right, or any other version control file, right? So because you would be probably modifying the same file, right? So the way, so, it is like, there are a couple of things to see here. So one is the Docker Hub part. One is the local management, the code version management tool, right? So the second thing is, like, for every commit that you do to a Docker file, right? Any changes that you do. So it's always good to have a tag with it, right? First thing. Second thing is, anyways, every build that you do has a unique ID, right? Any commit ID, any files you commit, there always a commit ID associated with that file, right? Second thing also is, it's always recommended to have tags, especially with Docker files. It's actually recommended in your because that is how CI/CD systems work. For continuous integration, it is a combination of your build numbers, and it's not always the latest build which works, right? So which is why it is tagging, plus obviously pushing the Docker to the main registry, and for the local needs of CI/CD and dev test areas, you would be using the build numbers along with the version of the file which is already there. Because probably I change something, then Venkat goes in, changes, then Murli also changes. So probably the latest version of the file might not be right, which is why you can reference build number for such purposes of CI/CD and deployment. And finally, anyways, once you push the images up into Docker Hub, right? Again, the ID will be changing, and then that is the one, whichever you are having the final one, that is the one which you use. And usually when we talk about CI and CD, right? So when you instruct, right, so this is a build number, not the latest might not be not good. So you might need to track back to previous week when Ganesh committed. So you would say, okay, take this file, but take this file with this build number, and then you push it to the Docker Hub. So it's actually a more the enterprise scenarios are always more complicated, but this is on a high level, this is what happens.
Yeah.
I slightly went off track, but I think it was important to address, how this issue is not, binary. It has more moving components in a enterprise scenario. Yeah.
See, we can get into depth. Docker is again an ocean, right? But whatever we had just shown you is the basic understanding of what an image is, what a container is, how do we run it, how do we pull the images, push the images, any changes, how do we work. So this is just the very basic that we had shown you. So Docker and Kubernetes itself is a 20 or 30 plus hours of training altogether. But I hope, with this, you got at least a basic understanding of what it is, correct? So tomorrow when, Ganesh is going to walk you through the pipeline modeler and creating few images here and there. So you should not go blank, right? So hope you have got a basic understanding, correct? Anyone, has any concerns, or you want me to repeat any of the things that I had already said? I really wanted to show you that accessing this Apache server, but somehow some port is blocking. So probably I will just, during our break, dinner break, I'll just see which port is blocking. I'll just try to do it.
Yeah, sure. Yeah, definitely, Venkat. Yeah, this is great so far. Like it gives a very good understanding, at least to me, that how this whole Docker process works and what we can do with that.
Exactly. So even, even with this image, whatever we had already built, right, you can also again create a container, commit a new image, and then do something. So if you see the image size, the base image, whatever we had taken was 72 MB, but the image, whatever we had committed is 210 MB. That is because of the Apache server that we had installed, right? Now, if you package it and give it to, push it into Docker Hub, and say, for example, if Ganesh is the tester, Ganesh can pull this image and he don't have to worry about the environment, because this itself is an environment that you had bundled. Correct?
Yeah.
He doesn't have to worry about anything. He just have to pull the image, spin up the container, and then check whether the application is working or not. Done. So as easy as it is, guys, you are able to see, right, how we are slowly moving from the traditional approach to the new generation open source technology world, how we make things easier. Now, if I have to correlate this to SAP Data Intelligence, SAP Data Intelligence has the images like this. These are all the images that will be available in your SAP repository: pipeline modeler images, monitoring images, system administration images. Like this, you will have hundreds of images corresponding to SAP Data Intelligence. Each and every image will be copied from SAP repository to customer repository, right? So this is the basic understanding. Not many people know this actually, how the behind the scenes work, but now I hope you would have a good understanding. Tomorrow if someone comes and asks you what about SAP repository, what it contains, how it is moving to customer repository, what are all these images, you should be able to have an outstanding answer, right?
Yep, definitely.
So I just did some changes, but looks like I don't have the permissions to open up the port in my Azure network. The administrator has not given the permission, so that is why probably it's not working. But I just did some changes, created a new image, and if you're able to see here, right, my port 82 has been mapped to port 80 of this container. So if I do sudo docker images, I have created a new image. So this is the naming convention that I had followed. Okay, so this is Venkat9890/my-apache. I will tell you why I have followed this. Now, what we did all this time was we downloaded an image, we installed Apache server, and then we port mapped, and when we want to access it, we can access it. We opened up a container right now. This is still in our local system, right? So if we have to push it to the Docker Hub, right? So if I have an account in Docker Hub, if I have to push it to the central repository, what is it that I have to do? So first of all, I have to log into my Docker Hub. So via CLI. So what I will do is I'll just do a sudo docker login. Now, what is the username? So this is the username that I had used to create the Docker Hub. So, and the password, just a second. Yes, login succeeded, right? So I was able to log on to my Docker Hub via CLI. Now, what is the command? To push this images, we have to sudo docker push, and then the Venkat9890/my-apache. Okay, so I am pushing my image, whatever I had created, the new image, to my Docker Hub, right? I will show you. So this is a naming convention that has to be followed whenever you have to push your image to the Docker Hub repository. Okay, so just so I have my repository. So I have already created a repository, Venkat9890/my-apache, and this is the repository name that I had given it as an image name, and then it has automatically uploaded here, right? So just a second, yeah. So this is what it is, and if I have to pull my if I have to pull the image, right, so I can just use this command to pull the image from my Docker Hub from this repository, right? So it will automatically pull this image from this repository. So this is how you do a push to your Docker this thing, and then you pull it from the Docker repository, right? So with this, we close the session for Dockers. There is also one more concept which I will explain you, which is called as Docker file, and then with that we will close the Docker section, and then we will move ahead with the Kubernetes. Okay, so we have something called as Docker file. Okay, so now what is it Docker file is used for? Now imagine whatever we had done is a manual activity, right? We pulled the image. Just let me quickly share that. Right, so we pulled the image, and then we had pushed the image, and then everything was manual activity. When I say manual activity, we had logged into the container. I had manually restarted the Apache. I have installed the Apache and then restarted the Apache, and then I had exited the container. So these are all some of the manual activities, but this is a very small step that we had done. Is it possible for us to automate this? Okay, if I just execute a script file, okay, if I execute a script file, automatically these things should be able to these things should be handled by the Docker. Is that possible? Yes, we have a concept called as Docker file, which will allow you to write certain set of commands which will execute in sequential order, and then you don't need to do anything. You just execute that using the Docker file. Automatically, everything will get updated. Okay, so I will just go through few of the commands, and I will also show you how the file will look like, so that in tomorrow's in your environment it is always advisable to use the Docker files instead of going inside the container and then manually doing the stuffs. So I will open up my whiteboard. I hope my pen should be charged by now, and let me know if you're able to see it. Okay, so I will just split this portion into two so that you are aware of what is happening. So, okay, so we have these basic commands from add, run, cmd, entry point, and then we have environment variables. Okay, so these are all the different commands that will go inside a Docker file that you create. So now, what is the from keyword is used for? From keyword is used to define the base image on which we are building it. Okay, now can anyone tell me what is the base image that we have used in our scenario for building up the Apache server and all those stuffs?
Also one that starts with Ubuntu or something, right? Like Ubuntu.
Yes, so we had the Ubuntu base image. So this is the base image that we had started. We always need a base image to start something, right? So we need, obviously we need an image to start working on, be it Ubuntu, Fedora OS, Windows, whatever it is. We need some image to start building our environment, right? So this is what it is. From is used to define the base image on which we will be building. Now, what is the second command that we are going to do here? Okay, so the second command is add. Okay, now add is used to add the files that the container is being built. Okay, so it will add the files from the current directory and then put it into the required directory that is available inside the container. Say for example, if I'll not give the add here, okay, just because there are few more steps, but just to, it will add all the files from one directory to another directory. Okay, so this is what add does. Now, when I give the command, you will be able to easily understand what it is. Now, third command is run. Okay, what did I do for Apache server? I did an apt-get update first to update the repository, correct? So this is what I had done. Now, what is the next thing after this I had done? I had installed the Apache server, correct? So apt-get install Apache 2. See, guys, these are individual commands that we had already given inside the container, and then we are just trying to make a file out of this. Okay, so from the base image, I run the update repository in the base image, and then I install the Apache 2. Now I am adding a certain file. So .var/www/html dot represents the current working directory. Okay, so whatever files that are available in the current working directory, it will get added to this var www.html. So this is your Apache server. As soon as your Apache server is installed, this path will be available, and whatever HTML files that you had given here, you can access it through the Apache server. So we are indicating, say for example, if you have an HTML file in the current directory, the dot, it will automatically pull in and it will put it in this path so that you will be able to access it. This is what add command will do. Now we have the cmd command. Okay, cmd command is probably all the important commands are over. So cmd command is used to run the commands on the start of the container. So whenever you start the container, these commands will run. Okay, say for example, if I have to run this Apache as a foreground service, then I will just use this command, Apache ctl. I think it is -d, yeah, foreground. So if you do this, it will probably run it as a foreground service. Your Apache services will be running as a foreground. Now, this cmd command is only at the start of the container. Only when your container starts, this command will run. This command will not run until and unless you start the container. Okay, and then we have something called as entry point. Okay, so entry point, whenever you start the container, if you have any additional commands that are going to get executed after the start of the container, entry point will execute. Okay, but CMD will not execute. Say for example, if you have to start the container, we gave some command, right? We gave the command as sudo docker run -it and then -d and then the image name, correct? Now if you don't give any other additional commands after this, CMD will run. Any other additional commands that you give here, CMD will get ignored and entry point will get executed. Entry point is irrespective of whatever command that you give for starting the containers. Even if you have any commands post this one, it will accept. Even if it is not there, it will accept. But CMD, apart from the run command, if you give anything, any other parameters are specified, then it will not run, right? So these are all the basic commands, and this is how you create a file. Env is nothing but your environment variable. You can set the environment variable in this file. Okay, so I will just quickly show you how to create it. Okay, how to create it, but I will not run it because considering the time, I will not run it. Okay, so just I will go back to my putty, and then I will show you what we can do there. Okay. So what I will do is, first of all, I will make a directory here. Okay, I will make a directory called as Docker files. Then what I will do is I will create a Docker file. Now nano Docker file. So this is what I'm creating. So whatever I have given there, I will just give it here. So probably, I will just give a very simple command. I will not give whatever we had given. Okay, so just for your understanding. So from Ubuntu, yes, from the base image, run app-get update. It will update the repository. So what I will do is I will do a CMD. I will do an echo, and then this is a text. Okay, so I'll just quickly save this. Right, so I will just do a cat Docker file. Yes, so this is what it is. Now, okay, guys, so I have created this Docker file. How do I build? Next is I have to build this Docker file so that it is available as a image for me, correct? When I start building this file, it will build an image automatically. So what is the command for it? So sudo docker build from the present directory, and then I build a custom Docker file. Sorry, yeah. See, it is running. You are able to see here, right? So from Ubuntu, step 1 by 3. Step 2, run app-get update. Now the third step is running, right? So successfully built, running, CMD echo. This is a test. So now if I go for sudo docker images, I will have my custom Docker file ready. Now I will run this sudo docker run, right? And what will be the command for it? And then I will just see fmd and then image ID. Okay, you see, as you're able to see here, this is a test. Whatever I had given in the step 3, right? CMD echo, this is a test. So what we did is we had a simple Docker file. It's a plain text file. We had given the commands from the base image, build, and then do an update repository. At the start of the container, you just do a simple echo and then return me this is a test, this value. So when I do a Docker run, the container will start. You know, right? The container will start at the start of the container. This is coming because CMD used to execute it at the start of the container. Okay. Now again, if you want to push it, you will be able to push it. You can then pull it from the image repository and all those stuff. Okay. Any questions? Okay. Excellent. So one more quick trivia before we move on to the next topic. So we have something called as Docker volumes. This will not be much useful to you, but just as a trivia or a fact, in order for us to persist the data, say for example, if I remove this container, then all my data is gone, right? Until and unless I publish the image or commit the image, all my data is gone. But if you attach a persistent volume to this container, even you delete the container, you can recreate the container using the data that has been saved in the persistent storage. So there is a separate section how you can actually attach the persistent volumes to your Docker images. So it's a big topic, but these are all the important things that you have to understand from data intelligence point of view. Okay, how to build a custom image, what is a Docker file, and then what is a container, how to start the container, how to get inside the container. So these are all some of the basic commands and overview of the Docker, that I really wanted to show you in the system.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.